This video will cover dividing decimals. Let's say you have some friends that want to go to an amusement park. So transportation and tickets for 12 friends to go to an amusement park is $364.20. How much will each person need to pay? So this ends up being a division problem, and it's got decimals, so we got to start by writing it down. So there's three different ways to write division. You can say it like this way with the division symbol here, 364.2 or 20 divided by 12. You can also write it as a fraction where the divisor is on top and the dividend is on the bottom. Or you can do it like this. I call this in the house. So you got the top number or the left number in the house, and the bottom number of the fraction or the right number of the division operation outside. So the divisor in the house, the dividend outside. Before we continue with this problem, let me just quickly go over that again. So let's say we have this problem here. So division, what goes where? So we have 3 divided by 6. A lot of students would look at this and say, well, it's 2 because 6 goes in the house and 3 is outside. But keep in mind as we go through this year and into 7th grade and 8th grade that some divisions will come out as decimals. So you can't just rely on the fact that 6 and 3 are compatible and the fact that 6 divided by 3 is a whole number that's 2. So you always have to remember that this left number is always a number that goes on the top of the fraction. Okay. If you do it in the house method, this number here on the left is always the one that's in the house. And this number on the right is always on the outside. Okay, so don't just rely on the fact that you need a whole number answer, because you will not always get one. Okay, so make sure that you are putting the numbers in the proper place. Alright, back to our division problem here. So we've determined that we can write it in 3 different ways. I find that the easiest way to do a problem like this will be using the house method. So let's bring it down, give ourselves a little more room. Doing long division with decimals is almost exactly the same as doing long division without decimals, with 1 or 2 small changes. The first change would be if there's a decimal inside the house, and you just simply move that decimal right up into the answer and then divide as normal. Later on we'll talk about what happens if there's a decimal outside the house. That makes things a little more difficult. So now we just do long division. So 12 does not go into 3. So I'm just going to put a 0 here. It's very, very important, probably of number 1 importance when you're doing long division, to line everything up properly. I see a lot of students making mistakes because they don't line things up, and so they end up putting the decimal in the wrong place. So definitely line things up here. 12 goes into 36 3 times. Do a little subtraction here. Some students find they have an easier time if they use grid paper to keep it lined up nicely. Every time you drop down a number, so here I drop down this 4, every time you drop down a number you have to get an answer up here. So 12 goes into 4 0 times. And now we can do the subtraction again. So we get 4 and 2. 12 goes into 42. Let's see, I think that's 3 times. We get 36. And 42 minus 36 is 6, bringing down this 0. And 12 goes into 65 times. And that will leave us with no remainder. If I bring this down here, 0 remainder. And so we can stop. Once you get to a 0 remainder, as long as you have exhausted all the digits in the house here, once you get to a 0 remainder, you can stop. So this is the answer, 30.35, and it is called a terminating decimal. Okay, we'll write that down. Terminating decimal, that means it stops, it terminates. Alright, so let's do another example. Let's say we had this problem here, 0.5 2.25 divided by 0.5. Now this is different than the last problem. Notice the last problem had a decimal in the house but nothing outside. In this one, there's a decimal in the house, but there's also one on the outside. And let's say we wanted to divide it by 6. Alright, and 6 goes into 12 2 times. Now let's say we were doing the same problem almost, but instead of 12.0 divided by 6, we're going to have 12.0 divided by 6.0, which we know is the same number as 6. And let's say I wanted to move this decimal over. If I also move this decimal over, you'll find that 60 goes into 120 2 times, just like the answer from over here. 120 divided by 60 is 2. And let's say I had that again, 6.0 divided by 12.0. Let's say instead I moved the decimal over twice and made this 600. And I did the same thing here and made this 1200. 1200 divided by 600 is 2. Let's take another look at this. Let's say I have this 12.0 again, and I have 6. Let's say instead of moving the decimal to the right, I decided to move it to the left. So it's right here. I'm going to move it to the left one time. So now I have 1.2 divided by 0.6. Let's take a look at a calculator here. So again, we got 1.2 divided by 0.6. What do you think the answer is going to be? 1.2 divided by 0.6. Sure enough, we get 2 again. So what I'm trying to show you here is that if you move the decimal in the divisor and the dividend the same direction and the same amount of spaces, you'll still get the same answer. So you can move it one space to the right and get a 2. You can move it 2 to the right and get a 2. You can move it 1 to the left and you'll get a 2. So that's how we're going to solve or simplify this problem over here. We have 2.25 divided by 0.5. We're not allowed to divide things that have a decimal on the outside here. And the easiest way to get rid of a decimal is just to move it to the right. So if I were to move this to the right and move this to the right, it should still follow the same rules as over here. Whatever answer I get would still be correct for what we had before. So 22.5 divided by 5 should be the same thing as 2.25 divided by 0.5. And I'll show you on the calculator that that's true later. But the important thing is we need to not have a decimal out here. And remember, having a 5.0 or a 5 point something, 5 point nothing, is the same as just a 5. And that's what our goal is to get this 5 all by itself. So now we can do the division. Remember, like I said, the decimal goes right up into the answer. 5 does not go into 2. It goes into 20, 2, 4 times. And then remember, when you're bringing numbers down, you don't need to move a decimal down here. Once we put it in the answer, we can forget about it. So now we can do 5 into 25, goes in 5 times. And so we think our answer is 4.5. Let's use a calculator to double check, because remember, the original problem we were working on was, let me get rid of that, was that 2.25 divided by 0.5. So let's check that out. 2.25 divided by 0.5, and we get 4.5. And once we move the decimal over to get rid of it, we also get 4.5. Okay, so whenever you get a decimal outside the house, make sure to move to the right until it is gone. Okay, let's try another. Okay, in this case, I started this out as a fraction just to give you a little practice changing it up. So we have this 0.2 divided by 0.06. And remember, if we use the house technique here, we're going to get 0.2 divided by 0.06. Okay, now remember, we cannot have two decimals, or we can't have a decimal outside the house here, so we need to move it out. Okay, and you got to move it out to the right. So let's use a different color. So I'm going to move this to the right, 1, 2, and that 0.06 now becomes a 6. The 0.2 became a 2, and now whenever there's an empty scoop here, you got to put a 0. So what was 0.06 into 0.2 now becomes 20 divided by 6, and that should give us the same answer. So let's see what happens. 6 does not go into 2. It goes into 23 times. Okay, now there was no decimal under here, but we don't have a 0 for the remainder. So what we have to do is put in a 0, a 0.0 actually. So we have to put in a decimal because we have to keep going until this decimal stops. So we're going to bring this down. So 6 goes into 23 times. And bring this down. And we're still not done. So we got to bring another 0 down. We just extend this bar out. So 6 goes into 23 times. So eventually, you may notice a pattern here. I'm just going to keep getting 3s forever and ever and ever. This is what's called a repeating decimal, meaning no matter how many zeros I add on the end here, I'm just going to keep getting 3s and it'll keep going. So that's a repeating decimal, and we show a repeating decimal with a line over the repeating number after the decimal. So instead of writing 3.3 and just writing that forever and ever, we write 3.3 and the bar goes right over that 3 there after the decimal. There are some times where the repeating decimal will be more than one thing. Okay, so if you were going to get something like, let's say the repeating decimal was 2.757575, and so on, you would just say, that means and so on, you would just say 2.75 and then put the bar over both numbers. And you can repeat with 3 numbers, or sorry, digits. You can repeat with 2 digits, 3 digits, 1 digit, or however many digits. So those are repeating decimals.